Good morning.
Good morning.
Good morning.
Okay, we have just 1 minute before official start. So is it okay if I start reading your names?
Yeah.
Yes.
Okay, today is April 15th. So Andrew,
Here.
Tima, I think I saw her name. Okay. Lorraine, Lynn,
Here.
Juanita, Yoran,
Here.
Gabriel,
Here.
Divina,
Here.
Kobe, Chantal,
Here.
Ricardo, Hochito, Gongsi,
Here.
Kyle,
Here.
Matthew,
Here.
Julian,
Here.
Nathan,
Here.
Alejandro,
Here.
okay, in about 5 minutes, I probably will read one more time. But what about my plan for today? I definitely, if you need any additional explanation of theoretical material, you are absolutely welcome to ask me, and I will try my best to answer your question. But mainly, I'm planning to solve problems today. How are you with that kind of plan?
Okay.
So,
Sounds good.
excuse me?
Sounds good.
Sounds good. Okay. I again assume that you had an opportunity to go over formulas, because again, it is very important to know these formulas, because each time when you solve any trigonometric problem, in one problem when we can apply several formulas, and you need to know which formula should be used, how it should be used. Quite many times you can solve the same problem using many different methods. Let me show you the last problem which we worked with yesterday, and after that we will go from there. Is it that problem at the bottom?
Yeah.
Okay. Thank you. So I would like to ask you to go to page 303, and you can choose, as soon as I start talking, it was already, oh, okay, I really apologize. So on page 303, you can choose right now any problem from number 2 to 7 and tell me about the problem which you like to see right now at the beginning of our class. We will be working with that. Which problem would you like to work with from 2 to 7? Only let's try to do that a little bit faster, because time is also really important.
How about 3?
Number 3?
Yeah.
Is it okay with everyone?
Yeah.
Yes.
So number 3, what should we do here? It's now, right now I'm going to read this from the textbook. In exercises 3 to 7, evaluate without using a calculator. In number 3, we have a tangent of 90 degrees. Same problem can look as, let's say, tangent of pi over 2. What is the value of tangent of 90 degrees? Here, it was quite a tricky question because this value is undefined. Tangent of 90 degrees is undefined. This value does not exist. So you just can write undefined, or you can use the symbol. Usually we are placing this in front of this expression, and this is the symbol of non-existence in mathematics. Can you see? This is capital E Latin, from Latin alphabet, turn to the other side, but I am crossing that symbol, which means does not exist. Because all vertical quadrantal angles, are out of the domain for tangent. This is why this value is non-existing. What about, let's say, same tangent? We have quite many tangents here in this part from 2 to 7. What about, let's say, number 6? Would you like to do number 6?
Yes.
Yeah.
It definitely we should expect an answer here because 120 degrees angle is not a vertical quadrantal angle. Okay. Number 6 has tangent of 120 degrees. And I wrote it down, tangent of 120 degrees. What is the location of that angle?
Second quadrant.
Second quadrant.
Second quadrant, practically. Is it between 90 degrees and 180?
Yes.
Yeah.
Greater than 90, less than 180. So, and how would you work? Let's try to apply that European method which I taught you. What can you do with that 120 degrees? You need to convert this into different look. It should be equal to 120, but it should look like sum or difference of certain angles. What would you recommend me? Let's talk about all possible options. Option number 1. Let's say if we are using 90 degrees, how can I rewrite 120 degrees using 90?
Add
Plus 60.
Can you repeat one more time?
Plus 30.
90 degrees plus 30, definitely. What is the other option if we are using 180 degrees?
minus 60.
180 minus 60 degrees, yes. Now you just need to choose one of these options because we are not obligated to show 2 different approaches. Which one would you choose? 180 degrees minus 60 degrees or 90 degrees plus 30 degrees?
180.
180. So in this case, rewrite this problem in different form. In different form, which means you can see I'm keeping the same tangent and I'm writing down 180 degrees minus 60 degrees. Definitely the shortest method here is to use that European method. Let's talk. Is it an angle from the second quadrant?
Yeah.
Yeah. Yes.
In the second quadrant, tangent is positive or negative?
Negative. Negative.
Yeah. So immediately put equal sign and write down minus. Now, in this parenthesis, what kind of quadrantal angle do you have? Vertical or horizontal?
Horizontal.
Horizontal.
Leave the horizontal, and I'm going to use very short way to explain. In other words, when we have a horizontal quadrantal, do we switch or keep? And you understand what I mean, I hope.
You keep it.
We need to keep the same function, right? It will be tangent. What is the reference angle here?
60.
60 degrees. So please don't forget about degrees. So which means tangent of 180 degrees minus 60 degrees equals to negative tangent of 60 degrees. And now definitely you need to recall the value of tangent of 60 degrees to finish the problem. So it will be equal to minus, definitely it will be negative. What is the value of tangent of 60 degrees, dear ladies and gentlemen?
Square root of 3.
Accepted, so it will be square root of 3. This is your final answer. I'm not going to show on this paper right now other methods, but I will briefly go over other ways to solve the same problem. This is the shortest actually method. What about other methods? In another, let's say method number 2. In this case, you also can write, instead of tangent of 120 degrees, you can write tangent of parenthesis, let's say 180 degrees minus 60 degrees. After that, you can apply one of really important properties of tangent. Tangent is pi periodic function, the regular tangent, because we have two pi periodic functions, tangent and cotangent only. Other four basic trigonometric functions are 2 pi periodic or 360 degrees. So which means, using this property, we can drop 180 degrees. We will be left with tangent of minus 60 degrees. And now we need to apply another important property of tangent. Tangent is one of odd functions, because if we have all these families of functions, I'm talking about basic trigonometric functions. 4 functions are odd: sine, tangent, cotangent, and cosecant, and 2 functions are even: cosine and secant. So which means we can carry this minus all the way to the front, so it will be minus tangent of 60 degrees, which is the second step here. And after that, you just need to finish the problem. The answer is negative, yes, and tangent 60 degrees is equal to square root of 3. You are done. So this is the second method. Third method, which is probably the worst method, but it also is possible to actually use. Again, you can write that it is tangent of 180 degrees minus 60 degrees. And this time you need to apply formula for the tangent of difference of 2 angles, which is tangent of parenthesis alpha minus beta. And this formula is in the list of important formulas. And tangent of parenthesis alpha minus beta equals to fraction tangent alpha minus tangent beta. And downstairs in denominator, you have 1 plus tangent alpha times tangent beta. So Alpha here is 180 degrees, beta here is 60 degrees. You can plug it in, and in this case, you need to know values of tangent of 180, tangent of 60, plug it in, use algebra, simplify, and you will get the answer. It will be many more steps than we had in 2 previous methods. I'm not going probably to spend too much time telling you about all possible methods for every single problem, but this is a good demonstration that even in that very simple case, we can use this type of method. And another method is number 4 method, where you need to find 120 degrees in your XY coordinate on the circle. You need to show the end point on the terminal side of that circle. You need to find coordinates of 120, or maybe if, let's say, you have already circled with all these points around the circle, and you can find x coordinate and y coordinate. Write down x coordinate equals to such and such number, y coordinate equals to another number, and after that tangent is y coordinate divided by x coordinate, and you can get the same answer. I think everyone can agree with me that that method which we actually used is the most elegant and the shortest, not just because I introduced you with that method. I am not the person who created this method. This is existing method, and it is being used at many different countries. Okay, I am moving now to the next part, and you can choose your own problem. And again, we have just many tangents here. These are problems from 8 to 10. Which one would you like to work with right now? Would you like to work maybe with 10? I'm just recommending. I'm not pushing you to choose 10.
Yes, that's fine.
So I heard that it would be fine, right?
Yeah.
Okay, I am declaring number 10. What should we do here? Find the exact values without the calculator. Okay, tangent, parenthesis, minus 3 pi over 4. Is it okay if I, again, will apply that European method?
Yeah.
Yeah.
Okay,
Yes.
but let's simplify a little bit first. Can you see that minus in parentheses?
Yes.
Let's take care of that minus. We just talked about that, about tangent being what? Odd as a function. Take this minus out. It now is right in front of the tangent. Now we are left with tangent of 3 pi over 4. Definitely you need to carry this minus to the end. Now, 3 pi over 4. Which number closest to 3 is easily divided, can be divided by 4?
4.
Right. What about 3 pi if I'm keeping 4, which is the perfect number divisible by 4? Can I say that 3 pi is 4 pi minus 1 pi?
Yes.
So let's change the top of that fraction. Look what I wrote down. That now it is 4 pi minus pi. Definitely, I keep the same denominator. And now I will break this fraction into 2 pieces. So what I'm doing, definitely I will be keeping minus. Definitely I need to copy tangent symbol. 4 pi over 4, is it pi?
Yes.
Yes.
So, and look what we have right now in parentheses instead of that fraction. We have pi minus pi over 4. And now let's talk about that. If it is pi minus pi over 4, which is practically 180 degrees minus 45, is it an angle from the second quadrant?
Yes.
In the second quadrant, tangent is positive or negative?
Negative.
Negative.
Negative. So basically you already had that minus, right? You need to write it down as a minus because you need to have equal sign minus, and after that we will be simplifying that tangent of pi minus pi over 4. Another minus, right? Because it is actually pi minus pi over 4. You told me about the second quadrant. Guys, can you hear me?
Yeah.
Yes.
Okay, so now if you look at these parentheses, pi, is it vertical quadrantal or horizontal?
Horizontal.
Horizontal.
Should I keep tangent or I need to switch to cotangent?
Keep 10.
Keep it.
Keep it. What is the reference angle here?
Pi over 4.
Pi over 4.
Absolutely yes. And look what you get right now. You are getting minus, which we had, and in parentheses, we have the result of our discussion right now. It will be minus tangent of pi over 4. I think that this now expression is too crowded with minuses, right? If you have
Yeah.
minus, minus, is it just plus?
Yes.
Now, does it mean that we are getting tangent of just pi over 4?
Yeah.
What is the value of tangent of pi over 4?
Is it 1?
It is 1. It is 1, and we found that value. So far, so good?
Yeah.
Okay. Let's go to page 309. By the way, ladies and gentlemen, I already posted another online quiz, and I think it would be available in the second part of Friday for a whole day on Saturday and Sunday. Please don't miss that quiz. Okay, I'm on page number 309. Can you please choose one of problems from 1 through 7? I don't mind which one. I hope it would be not tangent again because we already, but even if you choose tangent, I will do the tangent. Please, which one would you like to see right now?
Number 6.
Okay, number 6. Can I remove this paper?
Yeah.
Guys?
Yes, that's
Okay, so let's copy number 6. What do we have in number 6? First, let's read the request. Find exact values without a calculator. And in number 6, we have a secant. Yeah, this is not our preferable function. We like to deal with, I don't know why, but many people prefer to switch from secants to another function, but it is absolutely normal. Secants 11 pi over 6. Secants is very close relative of cosine. And it will be very natural that people like cosine much better as a function than secants. I hope you do not say that you hate both, and secants and cosine. But if, let's say, I pretend, let's say I am pretending that I am a regular student. So what would I do? I would probably try to say, as I say warm goodbye to that secants, and look what I'm going to write it down. I know that secants is a reciprocal for cosine. So this y, I am replacing my secants but with using cosine. It is 1 over cosine of the absolutely same angle. You can see I switched to another function, but I did not change the angle. After that, I will be using that method to simplify that cosine of 11 pi over 6. Which number close to 11 is divisible by 6 without any problem?
12.
12. Can we say that 11 pi can be written like 12 pi minus 1 pi?
Yes.
Okay, let's do that. So now I have a cosine of downstairs in this fraction, cosine of 12 pi minus pi over 6. What should I do next, ladies and gentlemen? Can you help me? What should I write as the next step?
The 12 pi over 6 turns into 2 pi.
And
You minus
minus what?
pi over 6.
Right. Thank you that you finish. This was not a mistake, but you finished this sentence correctly. Yes, it is cosine of 2 pi minus pi over 6. What is the location of this angle if you have 2 pi minus pi over 6?
Fourth quadrant.
Fourth quadrant, absolutely correct. In the fourth quadrant, cosine is positive or negative?
Positive.
Positive. In parentheses, do you have a vertical quadrantal angle or horizontal?
Horizontal.
Horizontal. Should I keep cosine or I need to switch to sine?
Keep it.
Keep.
Keep. So look what we have right now. Definitely it is up to you to write this plus. I did it purposely to put emphasis on that part. It will be 1 over positive cosine of pi over 6. And now you need to recall the value of cosine of pi over 6. What is the value of cosine of pi over 6?
Square root of 3.
Not. It is, if it is just square root of 3, it will be about 1.7. Cosine of any angle cannot be greater than 1. But square root of 3 is there. Can you be more specific? It is square root of 3 divided by 2. So this now what we have, but I need to simplify that. So we have 2 square root of 3 is downstairs, 2 divided by square root of 3, and I cannot declare this as a final answer because according to math rules, we cannot have irrationalities in denominator. So I am going to multiply top and the bottom by square root of 3. This lets me now say that we have only one step left to the answer. So the answer is 2 square root of 3 over 3. Now it is our final answer. 2 square root of 3 over 3. And I am done. Questions?
No.
Can we move to another problem?
Yes.
Okay, so let's move to another spot here. Let's say from 8 to 15, same page. What should we do here? In exercises 8 through 15, simplify the expression. In parentheses, we have additional things for values of the variable for which it is defined, definitely. Which problem would you like to choose? Let's do that. Let's have here, let's say, more than one problem from this spot. Which one would you like to see, 8 or 9?
9.
9?
Yes.
Okay. You are not obligated to surround here to theta by parentheses. It is not a mistake, but it is something extra. This is why I am going to write it down without parentheses. I do not like extra stuff when it is not a requirement. So number 9, cosine square of 2 theta plus sine square of 2 theta. Cosine square of 2 theta plus sine square of 2 theta. Okay. Do you have any formula in trigonometry in which you have the sum of squares of sine and cosine?
Yes.
And what does it say? I'm talking about formula.
Cosine squared t plus sine squared t equals 1.
Right. And you know what? This formula is universal. You can have any angle under symbols of sine and cosine in this formula. What is the angle here in our case? Is it 2 theta?
Yes.
Yes.
So which means sine squared and cosine squared of 2 theta are being added here in this expression. Is it correct?
Yeah.
Yes.
What would be the answer?
1.
1. Because I can have any angle here. 2 theta, half of theta, 2000 theta, negative 3 million of theta. It doesn't matter. Sine squared of any angle plus cosine square of the same angle is 1. This is an identity. This is the identity which has a special name. We call it Pythagorean identity of trigonometry or a basic identity of trigonometry. Okay, 10 or 11?
10.
10.
Okay, 10. 3 sine of t minus 2 1 minus 2 sine t. Can you please check if I copied correctly?
Yeah.
Okay. Let's simplify using simple algebra. Can you see that negative 2 in front of parentheses?
Huh?
Can we distribute?
Yeah.
Yes?
Yes.
So 3 sine t minus 2 plus 4 sine t. Agree?
Yes.
Mm-hmm.
So equals here. Do we have here like terms?
Yeah.
Yes.
Are they both carrying sine t?
Yes.
In one case, this is 3 sine of t. In other case of the term, it is 4 sine t. Can we add them?
Yes.
If you add them, what do you get?
7 sine.
Is it 7 sine t?
Yes.
Yeah.
Should we just copy -2 because it did not have any other term to be added to or subtracted?
Yes.
That's it. We actually did not use here any trigonometry. We just used simple algebra. Would you like to have number 13 and 15 or both? Again, number 13 or 15 or both?
13.
13, okay. 1 minus sine squared t over cosine t. On the side, I will remind you a formula. Sine squared t plus cosine squared t equals to 1, right? We just talked about this formula.
Yeah.
If I need to solve it for cosine, should I first solve it for cosine square, right?
Yes.
Is it cosine squared t equal to 1 minus sine squared?
Yeah.
Yes.
If I need to solve the same formula for sine, should I first solve it for sine squared?
Yes.
Can you see what I wrote on the side? I wrote it for both occasions. So we got two formulas from the main one, which is sine squared t plus cosine squared t. Using that formula, can I say that on the top of this fraction, instead of 1 minus sine squared t, I can just write cosine squared t?
Yeah.
Yes.
So, which means now, instead of original problem, can I have cosine squared t over cosine t?
Yeah.
Can we cancel by 1 power of cosine t?
Yeah.
Yeah.
Is it same thing like a squared divided by a?
Yes.
And this is your answer. You know what? Actually, 15 is quite interesting. Is it okay if we do number 15?
Yes. That's
Okay, 15. Parenthesis, sine x minus cosine x, close parenthesis, square, plus 2 sine x cosine x, double product of sine and cosine. This is the problem. Let's use algebra first, because that expression at the beginning, sine x minus cosine x squared, does it remind you a minus b parenthesis squared?
Yeah.
Yeah, it is same actual expression from algebraic point of view. Only instead of a, we have here sine x. Instead of b, we have cosine x. So we are applying that formula. It is a formula for the square of difference of two numbers. So which has what? A squared minus 2 times a times b and plus b squared. So consider that a is sine x, b is cosine x. Instead of these parentheses with square, you will be getting sine square x minus 2 sine x times cosine x plus cosine x squared or cosine square x. And definitely I need to copy what I had in this problem, which is positive 2 sine x times cosine x. I'm getting such quite long expression. Do we have like terms?
Yeah.
Isn't that two double products, one with minus, one with plus?
Yes.
Can we cancel them?
Yeah.
What is left? Is it sine square x plus cosine square x?
Yeah.
Yeah.
Is it 1?
Yes.
That's it. We got the answer. Okay. Let's go to page 310. And can you look at problem number 17? It's, what do we have here? What are the coordinates of the point Q corresponding to angle T plus pi? T plus pi. There are A, B, C, and D parts. I prefer to show one of, let's say, parts. Is it okay if I show 17A?
Yeah.
Yes.
Okay. Page 310. So what do we have? Let's say we have a point Q with coordinates x, y. Because if we need to say something about coordinates of the point corresponding to, actually, let's do what? Let's have, I will do that easier. Let's say that point P is given, and this is for angle T. I really apologize, I changed. It will be more transparent. Let's say we had originally angle T and corresponding point for this angle. Doesn't matter if it is in the unit trigonometric circle or in any trigonometric circle, the end point on the terminal side for this angle is point P, and it has coordinates x and y. And we have another point Q, and we do not know its coordinates, but we know that angle right now is T plus pi. You can see I put 2 question marks as coordinates for Q. Okay. Do you understand that coordinates of these points depend on cosine and sine of angles which we have, right?
Yeah.
So I'm going to start with x coordinate for theta, and I will name it like x with index q, xq. This is what I wrote, x for q. X for q equals, x coordinate is affiliated with cosine. And if we do not know that type of, what kind of circle we need to consider, a unit trigonometric circle or any trigonometric, I will assume that the radius is r. If it is a unit, so r will be equal to 1. So it will be r times cosine of the corresponding angle. Corresponding angle for a q is T plus pi. So this is what we have. X q equals to r times cosine of that angle. And now let's talk about this cosine of t plus pi. Actually, can I rewrite this like cosine of pi plus t? Yes?
Yes.
Now, pi plus t, is it the third quadrant?
Yes.
In the third
Mhm.
quadrant, cosine is positive or negative?
Negative.
Negative, so it will be minus r. Now, pi plus t, pi, is it a horizontal quadrantal?
Yes.
So, does it mean that for this point, we actually have x equal to negative r times cosine t? Yes? What about point P? I'm going to write here point P coordinates using cosine and sine. And I assume that they are in the same circle. So it will be r cosine t, comma, r sine t. I'm writing this right now. I wrote it on the side. Can you see? If pxy is the corresponding point for angle T, then P has the following coordinates. Can you compare X for P with X with Q? Can you see they differ only by -1 as a coefficient? Yes?
Yeah.
And if you remember, just X was coordinate for P. So which means it is equal to minus X. In the same manner, Y for Q. Y for Q equals to R times sine of the angle. Angle is T plus pi. This is R of times sine of pi plus T. The beginning is practically the same, only now we're dealing with sine. And now, again, this is the third quadrant's angle. Sine is negative, so it will be minus R sine of t again, because it was a horizontal quadrantal. So, and again, comparing this with point P's coordinates, what do we see? That it is minus y. So practically the answer here is Q has the following coordinates. If we have point P with coordinates x and y, then actually theta has coordinates minus x and minus y. They are opposite for x and opposite for y. And we are done. So you can see this is like indirectly we affiliated these coordinates of P with trigonometry, and we were able to find the relationship between coordinates of points of P and Q using trigonometry. Did you understand the process?
Yeah.
Yeah.
Okay, and can you, let's say, look at problem number 20. I hope I will have enough time. Can you start reading? And I forgot, I wanted to name some, call names of some students here. Tima. Tima. I see her name, but I don't know why she's not replying. Okay, so Lorraine.
Here.
Okay, Juanita. Kobe. Okay, who is that? Ricardo and Hochstel. Okay. What do we have in problem number 20? Give the exact answers for angles, angle theta between 0 and pi over 2. So let's see what we have here in problem number 20. In number 20, we have location for the angle, and we know that cosine of theta equals to 1/2. And what do we need to find? We need to find cosecant theta, and we need to find cotangent theta. Cosecant and cotangent. Looking at this location from 0 to pi over 2, can we say that it is basically the first quadrant with its ends?
Yeah.
Okay, keep it in your mind. I just wrote it right here and boxed that, so to make it visible. Now, I need to find cosecant. Is it true that cosecant is a reciprocal of sine?
Yeah.
If we need to find cosecant, is it going to be really good idea to find sine theta?
Yes.
Yes, but we have value of cosine. Can I say that sine squared theta equals to 1 minus cosine squared theta? We already talked about that. Yes?
Yes.
What did I use? I used that identity, that sine squared theta plus cosine squared theta equals to 1. Plug your numbers. So it will be sine squared theta equals 1 minus 1/4, because 1/2 squared is 1/4, which means sine squared theta equals 3/4. But I don't need the value of sine squared theta. I need to know this value of sine in the first power. So I will take square root from both sides. So, and I remember that it was first quadrant's angle. So in the first quadrant, sine is positive. So sine is equal here, square root of 3 over 2. Square root of 3 over 2. And it is perfect because cosecant is a reciprocal of sine, which means if sine is equal to 2 square root of 3 over 2, it will be 2 over square root of 3. But I cannot keep this as an answer because it has square root in denominator. What I do, I multiply top and the bottom by square root of 3, and voila, I will get the answer for cosecant. I answered first question. Cosecant is equal to 2 square root of 3 over 3. In the same manner, I will be working with cotangent, only using different formula. Cotangent of any angle equals to cosine of theta over sine of theta. So which means it will be 1/2 divided by square root of 3 over 2, which is, this is my telephone reminding that I need to finish. So, and it will be 1/2 multiplied by 2, because I replaced division by multiplication. Cancel this both 2's. So, and you are getting 1 over square root of 3. It is very easy to use the same strategy, multiplying top and bottom by square root of 3, and your answer is square root of 3 over 3. This is the value of your cotangent. So, and we are done with the problem. Oops, technical problem, I dropped. And we are done with second answer as well. Did you understand how we solve today's problems?
Yeah.
Yes.
Excellent. We will continue working with more problems, but again, you need to be very good friends with formulas and values of trigonometric functions. Please do everything what I recommend you to do. With your permission, can I finish our today's lecture?
Yes.
Yes.
Thank you. Everyone have a nice, beautiful day. Don't forget about formulas and homework assignments, okay? Bye.
Have a nice
Thank you, you too, guys. I wish everyone the best. Stay well. Bye.